Chapter 2, Section 3, review. So, if I'm doing long division, where's the 2x squared plus 1 go? On the outside. And the 6x cubed plus 10x squared plus x plus 8 goes on the inside, correct? You're welcome. I do. Okay, now, what do I multiply 2x squared by to get 6x cubed? Notice I'm not missing any powers, so I don't have to put any zeros in there, okay? But I'm going to multiply this by 3x, so I'm going to put this over the 3x position. Remember that? Okay, multiply on the diagonal. 3x times 2x squared gives me 6x cubed. 3x times 1 gives me plus 3x, lining it up underneath of its like term. Now, what do you do in long division? You subtract them, so we're changing the sign, so the 6x cubes cancel out. I drop down the 10x squared. X minus 3x gives me minus 2x. Drop down the 8. Remember? I distribute. 3x times 2x squared gives me the 6x cubed. 3x times the 1 gives me the 3x. You with me? Okay, so now, what do I multiply 2x squared by to get 10x squared? Just a 5. So I have a 5 here. Now I distribute diagonally. 5 times 2x squared is 10x squared. 5 times 1 is? Put the 5 underneath the 8, and what do? Swap the signs. The 10x squared cancels out. I'm left with negative 2x plus 3. Can I multiply 2x squared by something to get negative 2x? No, so what is negative 2x plus 3 called? My remainder. So I'm going to have plus negative 2x plus 3 all over 2x squared plus 1, which was my divisor. Done. You have one problem like that on the test tomorrow. Make sense? Okay. The next section on the test was tell me the type of roots you're going to have algebraically. Now, this is an Algebra 2 skill, but this is what we were using, 3x squared plus 4x minus 5. Yes, my 3 has a little curly Q on it. I'm sorry. It got curly. 3x squared plus 4x minus 5. This is an Algebra 2 skill that you should be reusing whenever you're doing all this P over Q and Descartes stuff, right? Now, this was the discriminant, negative b plus or minus b squared minus 4ac all over 2a. When we talk about the discriminant, we are talking about this right here. Remember whenever I taught this, I went right over beside Connor and I went beside that poster and I said, look at the discriminant poster. That entire chart tells you everything you need to know. So what we need is A, B, and C. What is A? What is B? What is C? Negative 5. I am only going to do the b squared minus 4ac. B squared is going to be 4 squared minus 4 times 3 times negative 5. Now, I'm going to keep the square root there because it helps with your thought process for some reason. I don't know why. But many of you like to see that square root there to determine what you're going to be doing. So this gives me 16. A negative times a negative is a positive. 4 times 3 is 12 times 5 is 60. So this gives me the square root of 76. Now, can you take the square root of 76? Is 76 a perfect square? No. So you know what type of answers these are going to be? 2 irrational answers. Right? Right? Because it's not a perfect square. What if I would have had the square root of 36? That's a perfect square, which means I'd have 2 rational. What if I'd have had the square root of negative 23? 2 imaginary. What if I had the square root of 0? That's 0, which means I have a double root. Right? Okay? This was all from last year with the quadratic formula that you guys should be using. This is what you're applying whenever we're using the quadratic formula, okay? And since we're talking about roots, I needed your brain to be able to understand and apply that concept whenever you're doing P over Q and Descartes. You with me? So you have 4 questions like that. Very quick and easy. Do not make that more than what it is. And if you lose yourself, get up and take a walk around the room by my desk, by Connor. Say hello and keep walking after you read the poster. Yes? Okay, the next thing is this a factor? Is this a factor? Yep, is this a factor? I give you x minus 5 minus 2i. Remember, when we did that, what did I make you do? Synthetic division at what value? You remember, you set that equal to 0, and you solved that, so x is equal to 5 plus 2i. Do you remember that? So you're actually doing synthetic division at the value 5 plus 2i. Do you recall that? Am I missing any powers? 3, 2, 1, 0. No, I dropped down 1, -7, -1, and 87. Now, what am I dividing by? What am I dividing by? A complex number, which means when you do synthetic division at that complex number, y'all are going to need to grab your calculators, because do not mess this up because you refuse to grab the calculator. I'm not testing you over if you know how to multiply complex numbers. I'm testing you over the synthetic division, aren't I? So do not waste your time on this. So here we go. I drop down the 1, multiply on the diagonal. That gives me 5 plus 2i. What do I do vertically? Add to give you -2 plus 2i. This is where you need the graphing calculator to help you out. Do you absolutely have to have it? No. So tell me, what is 5 plus 2i times -2 plus 2i? Nope. Nope. -14 plus 6i is the correct answer. Please make sure you put parentheses around things. If you do not put parentheses around 5 plus 2i times parentheses -2 plus 2i, you will not get the right answer. Now add that together. That's going to give you -15 plus 6i. Now do it again. And what does that give you? -87. Thank you, Devin. To give you 0. So the question is this a factor? Yes, this is a factor. So what's my remainder? 0. What if it was not a factor? You would write what? No. And then what would be the remainder? The last number. Do we all understand that? You have one problem like that tomorrow. Next, find the polynomial with the given roots. Find the polynomial with the given roots. Talk to me. What were you thinking? Okay, so you all want to take this over the other side? X minus 5 is equal to 0. X minus 1 is equal to 2i. Is that what you're saying? Thank you. Before you even start this problem, you should have been looking for its matching partner in crime. What is the matching partner in crime to I plus 6 to 1 plus 2i? You should have immediately said, hey, I got to have its partner. Its partner is x is equal to 1 minus 2i. Many of you started to do the problem before you even realized how many roots you needed to have. So you tell me, what is the degree of the polynomial now that I need to look for? It has to be degree 3 because remember, a complex roots only come in pairs. I may only give you one, but you need to remember to write the second one down. Does that make sense? So now, I can go ahead and write these two together now as x minus 1 is equal to plus or minus 2i. Everyone see that? Square both sides to get rid of that lovely plus or minus. And I'm going to have x minus 1 times x minus 1 is equal to 4i squared. What's I squared equal, folks? Negative 1. So what this is going to be on the left-hand side is x squared minus 2x plus 1 is equal to negative 4. Notice I foiled that in my head. If you have to take more steps to do it, please do it. Now I'm going to bring that 4 over to give me x squared minus 2x plus 5 is equal to 0. Now what do I do? Am I done? Yes, we got to. I love that. That's hilarious. What that means is that we have to multiply the two polynomials together. So if I'm multiplying the two polynomials together, I have to FOIL. Okay. X cubed minus 2x squared plus 5x. Go to the next one. Minus 5x squared plus 10x minus 25. Combine like terms, that gives me minus 7x squared plus 15x minus 25. There is an example of one of the polynomials that would have those three roots. Do we understand that? No? You have one like that on the test tomorrow. We good? Okay, where could we have gotten lost? Biggest issue is right here, would you agree? Does that make sense? I wrote this down 2 times, and I foiled the black right here to get this green on the left-hand side. Are you with me? Yes? 4i squared is negative 1 to give me the negative 4. Bring this over. Then these two are going to be married together. Whenever I say these two, I mean those ones right there. And it's a matter of just foiling from there. Okay? Are we good? You have one of those tomorrow. Okay, now, this is the bulk of the test. This is the big bad boys, okay? These are the problems that require P over Q, Descartes, graph it, synthetic division, and factor it completely. This is a problem that somebody gave me 3rd period that they were struggling with. Nobody had one, so she just gave me one immediately. So if you have this problem, step 1, P over Q. What is P? P is 45. It is your constant term. What is Q? 1, which is going to be your leading coefficient. Now, I need all the factors of 45. 1 and 45. 5 and 9, yes. 3 and 15, 5 and 9. Okay? Yes, I'm anal. I like to have them all in order. Am I going to dock you if they're not? No, I will not dock you. Okay? Now, what are all the factors of 1? 1. It's not going to matter. So what you're going to have is these numbers right here. Do we understand that? Okay, well, that's a beautiful thing because now we're going to go ahead and we're going to do our Descartes. Window. Glad you asked. What would be my window? Negative 46 to positive 46. Why is the window helpful again? We need to make sure that we have all the possible rational roots. The highest possible rational root is 45. The lowest possible rational root is negative 45. So we go 1 unit over so we can see that root, if it is a root, in that window, correct? Okay, so Descartes. How do I calculate Descartes? We're counting sign changes. And to do my positive roots, I count the sign changes in my original polynomial. Positive, 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 positive. Do I have any positive roots? Wow, that's interesting. What does that do to my P over Q list? There are no positives. So I went from having 2, 4, 6, 8, 10, 12 possible rational roots down to how many? 6 because I got rid of how many of the positive? All of them, which is half of them. Yes? Does that make sense? So now I reduced my list down to being -1, -3, -5, -9, -15, and -45. Is that helpful for me to know? Yes. So now do I need this window over here at 46? No, I can just go to 0, huh? Does that make sense? Do y'all see that? Okay. If you don't see it, do you have to change it? No. You'll just know that you're not going to have any positives whenever you cross it, okay? Negative. How do I find my negative roots? I need to do f at -x. I need to see this, y'all. If I don't see it, I'm docking points tomorrow. I do not have a book that has your brain as you were doing your test, so you need to write it down. What powers change? The odd powers change, so this becomes -x cubed. This stays at positive 5x squared. This changes to -9x, and this stays at positive 45. Does everybody see that, yes or no? Now, I need to count my sign changes again, right? So I'm going to have 1, 2, 3 sign changes. So how many possible negative roots am I going to have? 3 or 1. Why am I getting the 1? I have to subtract 2, okay? Am I done? We want to make the chart because if we make the chart, we get a good idea of what's happening in this graph, right? How many total roots is this thing going to have? 3, because its highest exponent is 3. So how many positive roots am I going to have? 0, and I can pair that with 3 negatives, which leaves how many imaginary? 0. Okay, I still have 0 positive roots, but now I compare it with what number? 1, and that gives me a grand total of 3 that I have to give me how many left to be imaginary. Can I have an odd number of imaginary roots? No. So this column for imaginary has got to be what? Even numbers, or 0. Do we get that? Okay. Now, we need to go ahead and we need to graph this. Because when we graph this, this is going to tell us a lot of information. So I went to graph that, and the problem was what? 3x cubed plus 5x squared, x plus 45. Okay, there's my graph. Well, how many do I know I'm going to have right now? I have to have at least 1. So I have at least 1. But could I have 2 more? I could. So what do I need to do? I need to change my window by hitting menu, window, zoom, and then go to window settings. But what did I say I could change my window settings to become now? -46 to 0 would be fine with me, because why? There's not going to be any positive roots because Descartes tells me that. Look at this. How many roots do I have? 1. So if we go back to our Descartes, you know what that tells me? That tells me that my answer, I'm looking for this right here, which tells me what? What type of roots am I going to have? I have to have 2 imaginary roots, which leads me to have to do that Descartes rule of signs, correct? Do we all understand that? Not Descartes, the quadratic formula, unless I can solve it outright, okay? So I come back over here, and I need to go back to my graphing calculator, and I need to find out what that root is. So I'm going to hit Menu, Analyze Graph, and hit 0. Click, click, and what's that root going to be? -5, 0. So if my root's -5, 0, I need to find 2 more roots, right? So I have root 1, -5. Root 2, I don't know. And then root 3, I don't know. Make sense? Do I have to do synthetic division? Why? I don't have all my roots. And I know that 2 of my roots have got to be imaginary. So in order for me to find it, I have to do synthetic division to drop it down a degree. Okay? So I'm going to do synthetic division at -5. I drop down the 1, the 5, the 9, the 45. I check to make sure I'm not missing any powers. 3, 2, 1, 0. I'm golden, right? I do synthetic division. I drop down the 1. That gives me -5. That gives me 0. This gives me 0. That gives me 9. This gives me a -45. What degree is this? This is now degree 2. Is that what I want it to be? Yes. So what is the polynomial that I need to use now? Equals 0. Do I have to use the quadratic formula on that? No. I could. A would be 1, B would be 0, and C would be 9. But I don't have to use the quadratic formula on here because I can solve this outright. So what I'm going to do is subtract the 9. Then what? Take the square root of both sides, and I'm going to have x is equal to plus or minus I squared times 9. What is that going to give me? Plus or minus 3i. So now I come back up here, and what's root 2? What's root 3? So now I have all my roots, and what's that lovely final answer that I'm looking for? The complete factorization, which is going to be x plus 5, x minus 3i, and x plus 3i. Now I'm done. Does that make sense? That was letter E, yep. I do not care which order you have it in. You could have x minus 3i, then x plus 5, then x times, or x plus 3i. I don't care. Oh, no, I don't know why I put a double parenthesis there. Apparently, I got happy with my parentheses. Okay. Do we understand that? Now, many of you are struggling with what number? Okay. Now, what I'm hearing is worksheet 4, or worksheet 2, sorry. Number 4. So worksheet 2, number 4, the problem is 21x caret to the 4th minus 68x to the caret 3 plus 270x caret squared minus 276x plus 80. First of all, is that what you all have? I guarantee that's where everybody messed up. If you do not have this, you will not get the right graph. So I hit enter. Bam. I can see some things happening there. I can see 2 real roots, can't I? Now I can't see very well, so what I'm going to do is I'm going to zoom in to make my life a little bit easier. Oh, oopsie. Tried to grab my label and look what happened. Okay? I'm going to find my zeros. Menu, analyze graph, 0. To the left, to the right. That's an interesting decimal, don't you think? Menu, analyze graph, 0. Now, what does 0.667 look like to you? That's 2/3. Is that in your list? Yes. Now, does someone have the complete list of your P over Q values? Does somebody have them? Can I see, please? Thank you. The complete list of P over Q is going to be 4 7s, 2 7s, 8 7s, 1 7th, 4 thirds, 2 thirds, 8 thirds, 1 third, 4 21st. Okay, thank you, Haley. Okay, that's her complete list of P over Q values. Now, we got 0.667. You know where that is? That's right there. Agree? The other one is going to be what? 0.571. Can you tell me what decimal up there looks like close to a half? Well, I can tell you it's not these ones. I can tell you it's not 1/21st, right? Because half of 22 is going to be what? 11. 11, that's close. That's not going to be it. None of those are going to be it. That's over 1. That's over 1. 1/7 won't work. That's over 1. So that gives me 4 7s and 2 7s. Do we see that? Do you see how I use logic to figure out what it was close to? Okay? So based upon that, I'm going to come over here to my graphing calculator, and I am simply going to hit my calculator, and I'm going to say, well, what is 4 divided by 7 decimal? Is that the decimal equivalent? It is. So now what's my second real rational root? 4 7s. Does that make sense? So now what you need to be doing synthetic division at is root 1 is 4 7s, and root 2 is going to be 2/3, and root 3 and root 4 is going to be what? What do you think they're going to be? Imaginary. Does that make sense? Do we all understand where we had our mistake at on that problem? Now, there are checks and balance systems. Just like in government class where we're talking about all that jazz, checks and balances, it's the same way with this problem. That's what I like about these problems. P over Q and Descartes is there to help you to understand what is possible and what is not. Is it necessary for you to do P over Q and Descartes every time? No, it's not. If you get this process without doing all of that, then on the last 2 problems of the test, don't go through all of it. Does that make sense? Okay, for example, eyes on me. Eyes on me. Would like your attention, please. If I give you a polynomial and I give you an imaginary root and it's degree 4, I give you one imaginary root. What do you automatically know? You know its partner in crime, which is its conjugate, right? Yes? So that means you know 2 roots already. Which means you could do synthetic division and break it down to degree 2 then, right? But what should you do before you do any synthetic division? Why do we want to graph it first? Because if it's a real rational root there, do you have to do synthetic division? No. Okay? Work smarter, not harder. If you don't have to go through all the steps, then don't do it. If I've required you to go through all the steps, then you're going to have to do that. Do we all understand that? Do you feel a little bit better about the test? Okay, the test is tomorrow. Now, understand something. There's a lot going on there. Are you going to stress out and panic and freak out whenever you don't know what you're doing? No. You're going to do what you know how to do, and you're going to try to work yourself through the entire period. When you're done, you go home and you study. And you come back on Monday and you're going to finish it. Questions, comments, or concerns? For those of you who had questions, do you feel like your questions got answered now from what I did in class today? Yes. Okay, which problem? Okay, this is right off of the worksheet. And this says exactly what I was talking about. It's degree 3, right? What do I know? I know that my other root is negative 3i. Yes? Now on the test, what would you do immediately? Graph this. On the worksheet, though, I wanted you to practice doing synthetic division. So this gives me 3i. So that's 1 plus 3i. So this is going to give me a 3i And that's going to give me a 3i times 3i is going to be 9i squared, which is going to be a negative 9. So that's going to give me a 3i. 3i times 3i is going to be 9i squared, which is actually negative 9 to give me 0. Do we see that? I've multiplied it in my head because of time. 3i times 3i is 9i squared. I squared is negative 1 to give me negative 9. Okay? Then you're going to do it again at negative 3i, right? Drop this down. That gives me negative 3i. Those cancel out. That gives me 1. That gives me negative 3i. This gives me a 0. This became degree 2. This became degree 1, right? So my answer is going to be x plus 1 is equal to 0, so x is equal to negative 1. On the test, am I going to force you to do synthetic division on this? No, because logic tells you that if you get root 1 and root 2, then root 3 has to be a real number, and you can get that out of your graphing calculator. Okay? Test tomorrow, folks.